Okay, so once again, we are going to cover questions on projectile motion today. So there are about 15 different ways questions can be framed, can be asked on the projectile motion. We are going to look at 5 or 6 of them today. We covered the theory yesterday, so let me recap what we covered yesterday. For number 24, which in this we had a projectile projected from the ground, landing on the ground. We are given u, we are given theta. We quickly derive the formula for your maximum height, your range, maximum range, angle at which the range is maximum, and so on and so forth. Then we also touched upon number 25, wherein we saw the range, which is u squared sine 2 theta by g. That range is the same for theta and 90 minus theta. And why do I say that? Because when you look at sine 2 theta, if instead of theta, if you put down 90 minus theta, you get sine of 180 minus 2 theta, which is again sine 2 theta. Then in number 26, the scenario is not very different, but now the projectile is not thrown from the ground, but rather from a height. So remember, we have 3 equations to work with. One equation in the horizontal direction, which is your displacement is equals to u cos theta times t. In vertical direction, you have 2 equations, just like we had in case of one-dimensional motion. So once again, in the vertical direction, you have 2 independent equations. One was Vy is equals to uy plus at. The second one was displacement in the y direction, y is equals to uyt plus half at square. Then we also discussed some things that we will look in number 27. We figured out how do we find out the angle of the velocity, the angle the velocity vector makes with the horizontal at any point in time. How did we figure that out? We said tan of that angle, tan theta, is Vy by Vx, Vy by Vx. Now in 28, which is something we have not spoken about, is wherein we have a projectile, and then projectile hits some given geometry, right? Might be a staircase, might be a ladder, might be a wall, whatever geometry it might be, and we'll try and figure out where does it hit that particular given geometry. So that is interesting point there is, let's say if you're talking about intersection of the projectile curve and the straight line, let's say inclined line, making some angle alpha with the ground, then at the point of intersection, that point, those coordinates x and y at that point of intersection, they will satisfy both your trajectory equation of the projectile as well as the equation of the given geometry. And once again, what did we say about the equation of the trajectory? Equation of trajectory is your equation in y and x without time t, right? So you just eliminate time t, and we did that. And we got the equation as y is equals to x tan theta minus gx squared by cos theta. Okay. Chavi, is that you who has joined in? Or I think Manan, is that you, right? You have joined
Yes,
different ID?
Yes, sir.
Is that right, Manan?
Yes, sir.
Okay, your voice is very low. You just might want to check your microphone there. Okay, so let's start. Let's have some fun with the questions. So we'll try and do 2 per question type. So 5 question types, 10 questions, 1 hour. That's a little bit more relaxed than what you will see in the exam, okay? Okay, there we go, almost there. Finally here, okay. We did some questions. Let me see, what do we have in JEE Advanced? Fairly old question, will not worry about that. By the way, the equation of the trajectory, that's a parabolic equation, na? Chavi beta, y is equals to x tan theta minus gx square upon 2 u square cos square theta. Yes, Peter? That is the equation of a parabola, isn't that, Peter, Chavi? Ruchika, is that right or not, Peter? Can you prove that that's the equation of a projectile? Let's do this. We'll worry about that in a moment. Let's go ahead and solve this question. Let me read through the question. A ball whose kinetic energy is E is thrown at an angle of 45 degrees with a horizontal. Its kinetic energy at the highest point of its flight will be how much? For the students who will be listening in on the YouTube, just to give you a flavor of how we are approaching kinematics, we are going by.
Sir, E by 2.
Okay, let me go back to the live.
Yes, so E by 2.
E by 2. Okay.
Yes.
And why E by 2? Because your ux, which is u cos of 45, is equals to uy, right? The initial kinetic energy is half m ux square plus uy square. So if that is E, then half m ux square is E by 2. And at the topmost point, at the highest point, you do not have any vertical component. You only have the horizontal component, which is u cos theta, but u cos 45. So that's why E by 2. Good. Next one. I'll let you guys read through it. So for the students on YouTube, what we typically do is we look at the different applications of a concept, which is, what does that mean? That means in how many different ways the questions might test your understanding. Why is that important? Because if you know what are the different possible questions that can be framed, if you look at all of them, then obviously you are covering the concept from all possible angles, and there can be no surprises in the exam. It is proving to be quite effective. It is proving to be very effective. So if you guys are listening, then I would highly recommend to follow this approach. We call it the question types approach. So the entire physics has been broken down into 720 different question types, and those are different ways the questions are framed on different concepts. For example, projectile motion, as you will see, there are about 15 different ways questions are asked on projectile motion. Each different application requires different understanding, different approach, and in any case, hopefully you will get the gist of it as you go through the question. Yes, Peter, how are we doing on this question? What they're saying is that if you have, this is your target, you want to point your gun, they're saying how high above. So this is given to be 30 meters. They're asking for this edge. Essentially, we just need to figure out theta. U is given to be 100 meters per second. So range is yes. Yes, beta. Chavi, Ruchika, Manan. Yes, beta.
Yes.
See, the trick here was not so much the application of the equations of the projectile motion, but I'm sure you guys got stuck at the point when you know the range, you know u square, you know g, everything is known, but then you got this equation sine 2 theta is 0.03, right? Now it becomes difficult to figure out how do we proceed. Is that where you guys were stuck?
Yes, sir.
So beta, let's quickly do this math, right? So let me see if I can open up an Excel file and we'll look at the different values of sine function for different values of theta. And what we'll notice is that for small thetas, say for example, your 0.05 radians, the sine theta is also 0.05. Did that make sense, what I just said? So let me prove that to you guys. Give me a quick second. I'm going to launch an Excel file here. Let's see if I can do that quickly. Shavi beta, is that clear what we are doing?
Yes, sir.
Okay. Manan, while I'm setting up the Excel file, let me walk you guys through the solution here. So sine 2 theta is 0.03. If sine of something is very small, then angle will be equal to that value. So 2 theta actually is equals to 0.03. That means theta is 0.015. Now I used tan theta equals to h by 30, but for small theta, tan theta is equals to sine theta is equals to theta. Right? So this is how it looks like for very small thetas. Right? So you can see that this, we can use the angle is equals to arc length divided by the radius of curvature. Either way, you can say for very small theta, tan theta is approximately equals to sine theta, is approximately equals to theta. That's what we have done. Is that clear? Yes, Vida?
Sir, but how far is the very small go?
That's why, that's where I want to show you, but around 8 to 9 or 10 degrees, or what would that be in radians? Let me just see that. but around there you're okay. So, okay, there we go. So we have the Excel file now. So let me give me a quick second here. Okay, so let's do it. So we are trying to figure out sine of theta. And this is your theta. So let's say we're talking about, so let me do theta in degrees as well as in radians so that we can get a, so this is theta in degrees. And this one is theta in radians. So let's say we divide pi into 1 degree each, or maybe, sure, why not? Let's say this is equals to pi divided by 180. And then we go this into 2. So let me do this with this, plus pi divided by 180. And we'll carry on with this. Okay, and let me convert them into degrees. This radians into 180 divided by pi. So this is what we have in degrees. Now let's see till what degrees or till what radians this is a good approximation. Let's just take a sign of this. Okay. When you see the 0.017453, sign of that is also 0.017452. Can you guys see that? Yes, Pradeep?
Yes, sir.
So now let's just do pi by 2. See, pi by 2 is 1. So this is 1.5 and that gives you 1 here. But for the smaller, now to answer your question, actually it is very, very safe till at least 10 degrees. Even after that, it's quite okay. But where you should watch out for is your cos is not that reliable anymore. After your cos is deviating from 1, it becomes around 0.082, sorry, 0.88. Or not 0.88, sorry, 0.96. So that is a reasonable deviation, okay? That's a 4% deviation.
So until like was that like until 7-8 degrees, we can just assume cos theta to be like 1.
Yeah, absolutely. Till 10 degrees, you're quite okay. Right, 0.98. So cos theta is approximately equals to 1. Right, Peter? Everybody's clear? Manan?
Yes, sir.
Okay, let's go to the next question. Or have we done 2 questions of this one? I think we have done 2 questions. Let's go to the next one. So in the next one, we are looking at the scenario where the projectile will have the same range for 2 different angles of projections. What are those 2 different angle projections? Theta and 90 minus theta. For example, 30 degrees and 60 degrees. For both the angles, for the same initial velocity, the range would be the same. Okay. Let's go ahead and solve this one, Bino. Okay. Sahil, I'm just trying to figure out what your message is. Let me read through it. Maybe I'm not getting it entirely, but I think you are asking if the class has started. Maybe you're not there anymore. Okay, in any case, once again, if anybody has any doubts, please do leave comments. I'll try and answer them. If not immediately, then fairly shortly. Okay, so I'll go back to the live class.
सर ए आ रहा है
Yeah. So here I assume that you have already corrected and you've assumed that this is actually cos square theta. This is sine square.
यस
Okay.
सर मेरा भी आ गया.
Yes, sir.
Okay. Let's move on to the next question then.
Sir,
Yes, Peter.
ये वाली questions में इसमें तो हमने बोल दिया कि the reason is not the correct explanation, but what would be the correct explanation?
Let's go back. Ruchika, what did you say, Peter? You said B or A?
सर ए
A. So, Peter, what's your question? Chavi?
So this is not the correct explanation, right? But like,
But why is this not the correct explanation?
so because this is not really telling you much. It's just like,
Yeah. Yeah, this is tough. So what you are saying is, well, this is part of the thing, right? H1, H2 is this, yes. But then you need to write down the formula for range as well. so that we can then say, yes, your explanation is complete, right? We have only the reason only talks about the right hand side, does not talk about the left hand side. I think that's what your comment is, correct, Peter?
Yes, sir.
Let me see actually what the NTA release answer is. In general, in general, for most of such scenarios, there would be clarity. There would be clarity on whether this is the correct explanation or not. But I have noticed that in the JEE mains, there are some questions for which it's a fairly gray line. If you think logically about it, you can argue either way, like you argued here, that well, H1, H2 is this, but what about the range? So you have talked about the right hand side, you've not talked about the left hand side. But we cannot say, let's think it this way. We cannot say that this is not the correct explanation. You know what I mean? That would be a harder argument to make, that this is not the correct explanation. This is an incomplete, but not incorrect.
Yes. Okay.
Yes?
Yes, sir.
Complete, yes, but not incorrect. Incorrect means there is an erroneous. This does not apply. Either erroneous or they're talking about completely different thing altogether. Right? Nothing to do with R, H1, H2. So that might be your quick test to see which way you should tilt. Okay, next question. This looks like a fairly older question, so I'm going to take on an NT Abhyas question. A shell, let me just read through it. A shell bursts on contact with the ground and pieces from it fly in all directions with a velocity equal to 60 meters per second. If it is known that a man who is 180 meters away is in danger for a time interval of square root x seconds, then what is the value of x? Then what is the value of x? It says neglect the height of the man, otherwise the question will get slightly interesting. Neglect the height of the man. Are you able to get the logic behind the question?
So इसका आंसर 72 है क्या?
72. 72 seconds? Or square root of 7?
So root 72.
Yes, sir, root 72.
Okay. Is that how you guys approached it, or you approached it differently?
The same method.
Sorry, say that again, beta.
It's the same method.
Same. And how did you get sine 15?
So sine 45 minus 30.
Good. Something along these lines? Okay. What about Ruchika? What about sine of 5 pi by 12, beta? That is 75 degrees. How did you go about that?
Sir, you could use the property of sine A minus sine B.
And what angles did you take? What was A and B for sine 75?
Sir, it will be simply sine 75 minus sine 15, which can be written as 2 cos 45 and into sine 30.
So you use the sine A minus sine B.
Yes, sir.
Manan, did you use this beta, or did you convert sine 75 into sine 60 plus sine 15?
So मैंने भी sinus minus मैंने भी किया.
Sine A minus sine. Okay, Chavi beta, shall I quickly go through the concept as I see it, and then we'll have a discussion?
Yes, sir.
Okay, so let me just quickly check the answer as well, just to make sure that there is no miss in the concept here. Okay. So beta, so we know the range, the same range you can have for two different angles, right? So now the time of flight is 2u sine theta by g, right? So smaller the theta, smaller the time of flight. So once again, I said 180 meters. If you want to fly 180 meters, you can do that for two different angles. Now, for the smaller angle, time of flight is small. For the bigger angle, the time of flight will be larger. Now, the person sitting on the ground at that point, at 180 meters from the location where the shell exploded, that person is in danger for this duration, right? So between T1 and T2. Now, you might argue, right? So you might argue that, sir, actually, why is the person in danger for the entire time interval, right? So there is nothing else going on. So why are we even worrying about the? So we should say he's in danger. He or she is in danger at T1 and at T2. How would you argue that, Beta? I think the question itself is a little bit ambiguous there. Now I don't have a good answer for that. Why would the, it says pieces from it fly in all directions, right? This is interesting. What about the other pieces, right? So there are sorry about the background noise there. Now the
Sir,
yes, madam.
so जैसे आपने सॉल्व किया था आपने डायरेक्टली फॉर्मूला अप्लाई किया but I just like I used from the starting like from x is equal to u cos theta t वहां से instead of going directly with range and time formula.
And that's not a bad thing. That's actually a good thing. So you said, okay, I don't remember the formula. Let me quickly find that. So now, how did you approach finding the formula, the range? Of course, you said y, the vertical displacement should be 0. So you figured out the time, and once you figured out the time of flight, that's what you have, right?
Yes sir.
Okay.
So पहले थीटा निकाल के फिर बाकी सब निकाला.
Okay. So you worked out the theta first. Okay, I see. This is how we did that as well. ना? अपने में theta निकालना बेटा. We also got the theta, no? Remember we said 2 theta came out to be pi by 6, so theta came out to be pi by 12. So theta 1 is pi by 12. The other theta is 90 minus pi by 12. Or pi by 2 minus pi by 12. That was 5 pi by 12. Those were the two angles we got. Okay, I'll not spend much time on it, but I'll tell you where I am still scratching my head. Is there a way to convince that no matter what the height of the person is, they said neglect the height of the person, then if the other particles, they are going to be flying past the or very nearly from that point, 180 meters, will they be passing that point at that between that time range? I'm not so sure. No, that may not be the case. Okay. For every other this is interesting. Wow, this is interesting. Now, if you assume that every piece that comes off that bursting of shell that has same speed, 60 meters per second, then would you be okay if I make the argument that between T1, which is when theta 1 is equals to pi by 15 degrees, and theta 2, which is 75 degrees, any shell with 60 meters per second fired between these two ranges, right, will be passing that 180 meters mark, no? And they will be passing it between these two time periods. So that's where, if the man is short or tall, doesn't matter if the man is half a feet or 6 feet, half a feet is a poor joke, but any standard height, then truly that person is exposed for that time duration. I think this was to help when they said neglect the height of the man. That helped people get to the answer. But if you think about it, actually that would be the right way to approach it. Correct, no?
Yes.
Manan, you got it? What I'm trying to say, Vida? That between T1 and T2, shells released at any other angle between these thetas will be passing the 180 meters mark within that time frame. Yes, Vida?
Yes, sir. Yes, sir.
And any shell fired between 75 degrees to 90 degrees will not reach that. Any shell fired between 0 degrees to 15 degrees again will not reach that. Any shell fired between theta equals to 15 and theta is equals to 75, they will cross the 180 marks this time duration. So that's why the man or woman, whoever is standing there, they are exposed for that duration. Okay, I think we got it. Next one. Chavi, beta, you got it now? What I was trying to say?
Yes, sir.
Let me just read through it and see if we should solve it. An artillery piece which consistently shoots its shells with the same muzzle speed has a maximum range R. To hit a target which is R by 2 from the gun, and on the same level, the angle of elevation of the gun should be. I think this is just a matter of figuring out the math. So let's go ahead and move to the next question type on projectile motion, where the projectile is dispatched or it's fired from a certain height. Right? Now, if somebody says what is the horizontal distance it will cover just before hitting the ground, then how would you approach it? Well, you know now your vertical displacement is that height h. And if you put that in there, if I have to write the equations, what will those equations be? If the height is h, then in the vertical direction I can write y, which is minus h if you assume origin is 0, 0, and vertical direction is positive. By the time the particle hits here, the vertical displacement is minus h. U sine theta, time of flight t, minus half gt squared. From this equation, you can find the time of flight t. Once you have the time of flight, then the horizontal distance is simply u cos theta into time of flight. Any questions there? No.
No.
Now, what about maximum height? How do you find the maximum height that the projectile reaches? At the maximum height, so let me first find this distance. Let me call it small h. So Vy square is equals to Uy square minus 2gh. So it's equals to Uy square upon 2g. U square sine square theta divided by 2g. So the net height is measured from the ground will be h plus h. So we have talked about this, we've talked about this. We've talked about the A and B. What is C? The time it will take to reach the ground. Of course, we have established that as well. Now let's go ahead and solve a few questions. Yes, please carry on.
So D.
Dia. Okay.
Yes, it's a DR.
Okay. Yes, Chavi Bita.
सर हमें नीचे
नीचे
की
की
रेंज
रेंज
निकालनी
निकालनी
कि
कि
क्या
क्या
निकालना
निकालना
एग्जैक्टली?
एग्जैक्टली?
I mean, see, initially I also thought that they are interested in D. They're not talking about the horizontal distance, they're talking about the overall distance. Square root of h square plus d square.
ओके
ओके
सर
सर
फिर
फिर
आ
आ
गया,
गया,
हाँ
हाँ
सर।
सर।
Okay?
यस।
यस।
Well, let's skip it. This is fairly simple and straightforward. No need to worry about this. Let's look at this question. It seems interesting. So I'll read through it. If this is interesting, we'll solve it. Otherwise, we'll move on. In a spring gun having spring constant 100 newtons per meter, a small ball B of mass 100 grams is put in its barrel by compressing the spring through 0.05 meters. There should be a box placed at a distance d on the ground so that the ball falls in it. If the ball leaves the gun horizontally at a height of 2 meters above the ground, what is the value of d? Well, um, this is just like what we solved in the helicopter scenario. So we are trying to find out the the distance d, which is going to be half gt squared because there is no vertical component. Sorry, h is half gt squared. The distance would be simply v times the time of flight. Now, to find the initial velocity, that's where conservation of mechanical energy. So we have been given the compression of the spring that is 0.05 meters, which means that the spring has been compressed by this much, which means the potential energy stored in the spring is half kx squared. What is potential energy? Potential energy is the amount of work, the negative of the work done by the conservative force. Simpler terms, delta U, change in its potential energy, will be equals to work done, which is equals to the change in the kinetic. Delta U plus delta K equals to 0. So that will give half mv square equals to half kx square, will give us the velocity, initial speed or initial velocity of the ball. Any questions? Hope that made sense. Chavi beta, did that make sense? Ruchika, did it make sense, beta? What I was trying.
Yes.
Okay. So now let's look at these interesting scenarios. So here, instead of giving you u and theta, instead of giving you initial velocity and the projection angle theta, they'll give you some information about the projectile at some or at two different instants in its flight. For example, you might be given that at time t1, the angle that the velocity vector makes is theta 0, and you might be given that at time t equals to t2, the velocity vector is pointed in the horizontal direction, as shown in the diagram here. By the way, what does that imply? If the velocity vector becomes horizontal at time t2, that means the projectile has reached its maximum point. Now they might ask you, let's go ahead and find the range of the projectile. So, would you approach it? You guys tell me the steps. Anybody wants to volunteer?
सर इसमें क्या निकालना है?
Range निकालनी बेटा. What you are given is at time t equals to t1, at t is equals to t1, the v, the velocity at that time, right? So velocity at t1 makes an angle theta 0. Okay, and then it says at t is equals to t2, v at that time is along the horizontal direction. There are a couple of different ways you can solve it. Please take any approach that you are comfortable with.
सर अगर हम इनिशियल एंगल ऑफ पोजीशन निकालना है फिर हो जाएगा.
We can find out the initial angle of projection.
Yes sir.
Okay, how would we do that, beta? What are the equations? Please tell me the equations. I'll write them. I'll solve it for you guys. Anybody can take the
सर y डायरेक्शन में इक्वेशन का मोशन लिख सकते हैं.
So Vy at time t1 is equals to Uy minus GT1. And
Yes sir.
V at that point is U cos theta. So Vy by Vx, which is tan theta 0, is equal to U sin theta minus GT1 upon U cos theta. That is your first question. Yes, Petaji?
Yes sir.
Okay. What should we do next? What is the second equation? How many unknowns are there? U, theta. Two unknowns. So I need one more equation. So let's look at this one. At t equals to t2, your Vy becomes 0. That means u sine theta is equals to G. Can I say that? Yes.
सर मैं ये को सर निकले जाएगा सर अगर हम T2 पे देखें सर तो फिर UX equals to V at T2 हो जाएगा.
So u cos theta then is g T2 minus T1 divided by tan theta 0. So we can find out the angle. If you divide the two, square and add, you will find u. Yes, Peter? That's how you would approach it. Ruchika,
Yes, sir.
any different approach that comes to mind?
No, sir.
So the other approach is you can figure out, if you just take a look at this part of the motion, this is also a projectile motion. So now the time period between this and this is T2 minus T1, which will essentially will give you the same thing. It's not going to give you anything different. How would you approach there? So what will you get? You will get the velocity v there at that time. Right? Correct, Novitan? So what will be v? So if this is v, this is theta 0, this is T2 minus T1. We know the time of flight. Which is T2 minus T1. For this part, what is the time of flight, Peter? U sine theta by g. So v sine theta 0 by g.
Yes, sir.
Okay. So we got v as once we know v, we know ux, that is u cos theta, is equals to v cos theta 0, right? V cos theta 0. So that will be g T2 minus T1 upon tan theta 0, which is what we have here. Clear? What will be Vy? Vy will be V sine theta. Or we know this is Vy is V sine theta 0 is equals to U sine theta minus GT1. That is U sine theta is equals to V sine theta 0, which is GT2 minus T1 plus GT1. That is GT2, which is what we got here as well. Either approach is fine, doesn't really matter. Two unknowns and two equations. Once you know u and theta, you can figure out the range. Let's go ahead and solve some problems. Any questions, any doubts? Let's go ahead and solve this one, beta. 2022 question. Yes, beta, do we have an answer? For students on YouTube, the approach we are taking is fairly simple and straightforward. Always remember the intent is to write down your um, or whatever information is given at a certain time, let's say at in this case t equals 2 seconds, link that back to u cos theta and u sin theta, and you will get your desired equations, right? In this case, we have been given that the angle of launch is 45 degrees. So what does that mean? That tells us that the horizontal component of the initial velocity and the vertical component, they are the same. So uy is equals to ux. So we called it v. Now we have been given the magnitude of the velocity at t equals to 2 seconds. So from there, we can write vy, that is the vertical component of the velocity at t equals to 2 seconds, in terms of the uy. So vy is v minus 2g, where v is what once again, what is that? V is initial velocity times sine of 45 degrees. So minus 2g, which is minus gt. Similarly, for the horizontal component, that doesn't change. That is still v. So from there, we find out v is 40 meter per second. Once we use, v is 40 meter per second, which is the vertical component of the velocity. And from there, we are able to find the, I think I have made the simple mistake here. This should not be square root. There should not be any square root 2 here. So this is not 40 meters, but rather 80 meters. Because remember, this v is what? This v is the u cos 45 or u sin 45, which are one and the same thing. It should be 80 meters. So let me go back into the class now. Manan, how are we doing, beta? Shavi?
Circle.
Yes, beta? Ruchika? Beta, where are we stuck? Hope you guys can hear me.
Yes, sir, we can hear you.
Okay. Manan, beta, please do tell where are we stuck? You got it?
Yes, sir.
So you also approach a similar approach or anything interesting? Or maybe I misunderstood what you said. So were you able to solve it on your own, or you were looking at the what I wrote down here
Sir, I was looking at the screen.
at the screen? Okay. Ruchika, beta. Okay. Chabi, is it clear, beta, what we have done here?
Yes, so I was actually not looking, so I'm just like trying to solve it. Can you give me 2 minutes?
Yeah. Take your time, beta. Take your time. No rush. So I muted the online class, and for the students on the YouTube channel, what we do in the class is, and this is something that I stress upon quite a bit, is sometimes the teacher telling the concepts in the class, that's very important, right? But solving questions and giving students time to solve.
So can you hear me now?
Yes, Pita,
Yes, yes, I got the same answer.
you got the same 80 meters.
So actually, I got 20 meters. I'll just see where I went wrong.
Or maybe I have done some mistake. Let's check the answer, okay? Oh, you're right. What are they asking?
The maximum height.
It says UX is 20. No, that's not. So, okay, so let me do it again. Seems like I bungled it up. So UX is equals to UI. The VY. Let me write it here. And then V is equals to, or VY is equals to UY minus GT. T is 2 seconds minus 2G. Vx is Ux. We've been given the magnitude, which is Vx squared plus Vy squared. Let me set a square root. This is 20 meters per second. So I'm going to write 400 on this side. So let me put these in there. We'll get Uy minus 2G squared, or rather Ux squared plus this is equals to 400. 2G, I'm going to write this as 20. If I open this up, we get Ux squared plus Uy squared. I think I noticed where I have made the mistake here. That's okay. Minus 40 Uy is equals to 400. Now Uy equals to Ux. So let me replace Ux with Uy. So what do we get for Uy? We have 2 Uy square is equals to 40 Uy, or Uy is 20 meters per second. There was my error. Now the maximum height is Uy squared by 2G. So that is 20 squared by 20. That is 20 meters. Ruchika beta, you are correct. Manan, nothing has changed in the approach beta, just the error there. You guys need to make sure you don't make errors as I did. Shall we move on?
Yes, sir.
Chavi beta, can we move on?
Yes, sir. हाँ हो गया.
Okay na? So let's quickly look at the next question type as well. You guys can attempt, by the way, for this one, I would recommend that you attempt the anti-abhyas questions. Highly recommend it. Because these are slightly order field questions. So it's important that you get a confidence on how to approach these questions. Okay, now we're talking about projectile intersecting with the given geometry. So let's take an example or two so that we can. Well, let's do this. We are approaching the end of the class now. So let's take a break now and we'll resume tomorrow from this question type. But please do finish if not finish, at least do 3-4 questions from anti-abhyas for the previous question type. And we'll pick this one up, which is question number, I think, number 28. So we'll start with 28 tomorrow. Already, beta, I think we'll take a break now. and I'll see you guys tomorrow evening.
Thank you, sir.